Hi everybody, so welcome back. I hope you're all safe and well. This is the second video of the series and we're going to be looking at alkanes this time. So it would be a nice idea for you guys to have your National 5 data booklet open to page 6 for the first little bit of this video. We're going to be looking at other pages as we get further on in the video, but page 6 will be fine just now. So thinking about hydrocarbons. Hydrocarbons, as we saw in video 1, contain only hydrogen and carbon. So we're going to focus on those two elements and that's it. So carbon has the electron arrangement of 2, 4. It's got 6 electrons in total and that's arranged 2 in the first shell and 4 in the outer shell. So something like this. Keep in mind that our noble gases in group A are the most stable, and the reason for that is because they've got a full outer shell of electrons. So all atoms want to achieve a full outer shell, and for most atoms this is when they achieve 8 electrons in their outer shell. So for the purpose of this little demonstration, I'm not going to use this method of showing the outer electrons. I'm just going to use a sticky note here with 4 dots, and those 4 dots represent the 4 outer electrons, okay? So here's a carbon atom with 4 outer electrons. Keep in mind, it wants to have 8 outer electrons. So where's it going to get it from? Well, it's going to form, because it's a non-metal, covalent bonds with hydrogen. It's going to share electrons with hydrogen in order to achieve this stable outer electron arrangement. So it's got 4 outer electrons. It wants to have 8. Each hydrogen atom has 1 electron, so how many hydrogen atoms do we need to go from 4 to 8 electrons? So that would be 4. There's 1 there. There's 1 there. Here's our 3rd hydrogen atom and our 4th hydrogen atom. So now we've got 1 carbon atom and 4 hydrogen atom. Now you can see the carbon's got 1, 2, 3, 4, 5, 6, 7, 8 electrons, so it's stable. You can see the hydrogen has each got 2 electrons, so it's stable as well. So all the atoms here have got a stable electron arrangement, which means that this compound is the first in our alkanes homologous series. This is 1 carbon, 4 hydrogens. So if we go to page 9, you'll actually see a list here of 8 compounds, all ending in the 3 letters A-N-E, ane. And the first one you see here, methane, this is methane, CH4, methane. So, we have a look at this table now. We're going to think about the structure, the name, the molecular formula, depending on how many carbon atoms we have. So if we've got 1 carbon atom, we look at our table called methane. The molecular formula is simply the number of carbons and hydrogens within the structure. 1 carbon, 4 hydrogens. So write that as CH4. Don't need the 1. If you've got 1 atom, you don't need to show the number 1 in there. The full structural formula, well, as we can see, we've got 1 carbon in the middle, 4 hydrogens coming off each side. There we go, there's a full structural formula. That's where you show the lines represent those covalent bonds, okay? Now let's start building on that. Let's add another carbon atom. So remember, this is stable, so to add another carbon atom, we first need to take a hydrogen off to give us some space in there. So let's add another carbon atom. Just line it up with the carbon atom from before. So now they're bonded together. So this carbon here, the first one, has still got 4 outer electrons, but now it's made 1, 2, 3, 4 bonds, 3 with hydrogen, 1 with another carbon, so it's stable. But this new carbon we've introduced has 1, 2, 3 lone electrons. It's got 5 in total. It wants to have 8, so it needs to make 3 bonds. So let's add 3 hydrogens. There's 1 there, 2, and 3. So each carbon now has 3 hydrogens bonded to it, as well as being bonded to its neighbouring carbon atom. So let's look at our list now. Methane was when our hydrocarbon had only 1 carbon atom. Ethane is next on the list, and that's when you've got 2 carbon atoms. So let's go and add that to our table. Number of carbon atoms, 2. We call that ethane. How many carbons and hydrogens do we have? Well, we've got 2 carbons, so C2, and 6 hydrogens, H6. How am I going to draw the full structural formula for that? Same as what I did when I was using the sticky notes. Same as before, I've got a carbon atom with 3 hydrogens. And this time, as opposed to having a hydrogen coming off the right hand side as we did with methane, we've got another carbon atom. There we go, there's a second alkane within the homologous series, and that is ethane. Let's do one more. So add another carbon on. So take off this hydrogen, add another carbon. Again, now this carbon here is back to being stable. However, this carbon here has got 3 unpaired electrons. So let's add 3 hydrogens. 1, 2, and 3. There we go. Now, every atom within this molecule is stable as it's achieved its full outer electron shell. So let's finally add that to our table. 3 carbon atoms. We're going to call that propane now. That's the next one on the list. Propane. Its molecular formula, how many carbons and hydrogens it has. 3 carbons and 8 hydrogens there. C3H8. Then let's draw that out finally. This time I'm just going to draw the carbon chain in first, then add my hydrogens, making sure each carbon has got 4 bonds and only 4 bonds. And there we go. So now we'll know the relationship between the number of carbon atoms, the names of the molecule, which you can always find on page 9, the molecular formula, and the full structural formula. This pattern goes on. As you add another carbon on, you're going to have to add another 2 hydrogens on. So that would give us C4H10. And you can continue that as long as you want. So that means there's a relationship between the number of carbons and hydrogens. And if we think back to the definition of a homologous series, that's a family of hydrocarbons with the same general formula and similar chemical properties. So focusing on that general formula, how do we get from the number of carbons to the number of hydrogens? Do we add 3? Well, 1 plus 3 certainly gives you 4, but 2 plus 3 doesn't give you 6. 3 plus 3 doesn't give you 8. So we can't just add an arbitrary number on. We have to be a bit smarter with it. So how do we get from the number of carbons to the number of hydrogens? Let's say n represents the number of carbons. It could be any number. It could be 1, it could be 500. Hydrogen represents the number of hydrogens. So how do we get from the number of carbons to the number of hydrogens? We're going to double it and we're going to add 2. And that there is our general formula. And that general formula will work for methane, it will work for pentane, it will work for octane, it will work for an alkane with 90 carbon atoms. You double the number of carbons and you add 2 to get the number of hydrogens. So let's try it for octane, which would be C8. How do we get to the number of hydrogens? We double 8 to get 16, we're going to add 2 to get 18. C8, H18, and that would be the structural formula, the molecular formula, beg your pardon, for octane. Okay. So what I want you to do now is make sure you've got this in your head comprehensively. Make sure you've gone back to the assignment. If you've not completed this task within the assignment, make sure you've got 1 down to 8 completed. Any further questions, please let us know on the Teams, and the next video coming up will be on alkenes. Okay, thanks for listening, guys. Catch you later.